यस सर। जी सर। सर मैंने सबको जा जाके बोला है पर्सनली कि नीचे आ जाओ। एक बार मैं सेटअप करा दिया इसका, प्रोसेस फिर से करो एक बार। आई थिंक सर एक फाइनल कॉल आउट करवा देता हूँ। संजीव, फर्स्ट फ्लोर पे चला जाओ। तुरंत आ जाओ। जल्दी में। हेलो हेलो
हेलो। हेलो।
Hello, hello. Good morning, everyone. We're just waiting for a minute or two. There are people still at the tea counters upstairs, so they're all coming down. How many of you have traveled more than 10 kilometers to come to this place? Okay, that's quite a bit. How many have taken flights to come here? Wow, fantastic. So I'll just give you some background about today's event, why we are doing it, who's organizing it, and then we will formally kick off with the lamp lighting and invocation of the goddess of learning. My name is Anup Vadhva. I am involved with the Automation Industry Association and also involved with IIT Delhi. And what we are bringing here today is an amalgamation of vision between the two organizations, which culminated few years back into a not-for-profit foundation called the IITD-AIA Foundation for Smart Manufacturing, in short, FSM. Our motto is to make smart manufacturing a very simple process. And that is what we attempt through our various interventions. This is a new format which we are trying out first time, and with your blessings, we will succeed. This format is about taking certain key topics which we discovered in our journey. The topics starting from making legacy machines smart to building up the software infrastructure for a digital factory, and then to look at the conversations around artificial intelligence, machine learning, the buzzwords of every computer scientist, and then look at the maturity of the receiving organization in terms of process maturity to handle the data-based decision making. And finally, we have two modules which takes care of the human resource development. The first one is a session on skills. We'll be announcing a partnership in that session between our foundation and the ASDC, whose CEO has just walked into the room. And finally, we will take you on a conducted tour of our facility within the IIT Delhi campus. Our facility is spread in 3 locations, but we'll help you with the logistics. We have a shuttle of cars arranged to take you there. These facilities are meant for all of you. It's a common engineering facility supported jointly by AIA, IIT Delhi and the Government of India through the Ministry of Heavy Industry. तो ये आपकी फैसिलिटी है और हम चाहेंगे कि आप इसको अच्छी तरीके से देखें और अपने डेवलपमेंट के लिए, अपने टैलेंट ग्रोथ के लिए, अपने एक्सपेरिमेंटेशन के लिए इसको यूज़ करें. So we are at your service. This program is meant to introduce you to these topics and also to get to know each other. So we'll have sufficient breaks where we can network. If you have any questions, you have any support requirements, contact anybody who wears the badge of organizer. We'll there to help you. So without further ado, let me get started and request Naman, who's going to be your main anchor today, the Master of Ceremonies, and he will start with the Saraswati Vandana. Can we invite Professor Sunil Jha, Mr. Ravi Agarwal, Mr. Sunil Mehta, Mr. Arindam Lahiri. They are the main architects of this venture. So let's give them a big round of applause as they invoke the blessings on our behalf. Thank you.
शुक्लां ब्रह्मविचारसारपरमाम्
I think it's a digital technology we are using. The youngsters are forcing us to go digital. And I think that's what's happening all over.
हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्
They do reverse, I think. So with that, we formally start today's function. There are 5 sessions, as I mentioned. Naman will just take you through a small slideshow to brief the sessions, and then we start with the first session. Over to you, Naman.
Thank you, sir.
Naman, incidentally, is the first person who joined our foundation, and he's been a pillar right through. So please give him a big round of encouragement. Thank you.
सर फोन आपका So, a very good morning to all the guests. And as we are already running late with the program, I'll quickly take you to the sessions brief. So we have started with the inauguration, followed by the first session on making legacy machines smart and connected with our session experts, Mr. Sudhanshu Kantur, Mr. Vishwarachari, and Mr. Sunil Mehta. The next session will be on smart engineering using digital modeling and simulation. The third one goes for understanding the use cases of ML and AI in manufacturing. The fourth session will be on the process maturity and database decision making. And the last session, skilling for emerging job roles. The sessions will be followed up by a visit to FSM facilities, which will be the cyber physical factory, the cyber physical lab, and the training facility of FSM. So, moving ahead to the first session of the day, making legacy machines smart and connected, I would like to invite Mr. Sudhanshu Kantur, Mr. Vishwarachari, and Mr. Sunil Mehta, sir. A brief introduction about Mr. Kantur. Mr. Kantur is passionately involved in the field of industrial automation for now about 2 decades. He has been an avid programmer, software programmer in the control automation, have been leading technical and projects for the factory automation business vertical at Pepperell Fuchs India since 2008. He has been working across the control platforms and leading implementation of Industry 4.0 solutions for PNF factory automation business in India. Our next speaker, Mr. Vishwarachari, the head of Industry 4.0 Assistant General Manager at Hero MotoCorp Limited, brings a wealth of experience and expertise to his role. With a Bachelor of Technology in Mechanical Engineering from Manit and PGDM in Operations Management from IMT Ghaziabad, possesses a strong educational background. He is well balanced in business focused project strategy and development, program management, digital solutions, enterprise applications, and infrastructure services. He has an expertise in opportunity assessment, gap assessment, stakeholder management, and vendor management, change management, competitive landscaping, budgeting, benchmarking, and building digital transformation roadmaps to create new operating model by deploying innovative tech solutions to generate significant business value and enhancing customer experience. A third industry expert, Mr. Sunil Mehta sir, is the GM of Automotive Business Development Department within Mitsubishi Electric India, Factory Automation and Industrial Division, is a Bachelor of Engineering in Electronics and Telecommunications from MIT Pune. Notably, Mr. Mehta has played a pivotal role in developing automation solutions, enhancing facilities using Mitsubishi FA products for esteemed automotive clients like Maruti Suzuki and Honda cars. He currently leads the automotive business development and chairs the CLPA, aiming to expand the CC-Link network in Indian manufacturing industries. Mr. Mehta is the president of Automation Industry Association and the director at IITD-AIA Foundation for Smart Manufacturing, and is also an elected member of the CII National Council. A warm welcome to all our speakers, sir. I think Okay, so I would now like to call upon stage Mr. Sudhanshu Kantu sir to brief us on the topic. Over to you, sir. Please, here. Welcome, sir. I'm sorry for the technical glitch. There was some issue with the laptop one.
Okay. Thank you. Okay. Very good morning to all of you. Before I begin, I would like to thank AIA Association and Anup sir for giving me this opportunity to present in today's forum. And like before I was coming here, Anup sir said, you are the opening batsman. So it becomes a huge responsibility for me to set up the tone for the today's event. Like Naman said, I'm Sudhanshu and I look after the product management in Purple Fox. Today I shall be speaking about how to make legacy machines smarter and connectable. Right? This is the most important aspect today. So first of all, I would like to say that legacy machines were developed based on the technologies that were available at that time. So those technologies have now become a little obsolete. And as a result of that, it becomes very tedious or very difficult to make those machines come up to the expectations of what we want in the industry today. All these machines have certain amount of limitations, and to solve those limitations, there are a wide variety of solutions available in the industry. So I'll be sharing with you how these machines can be made smarter by providing different type of solutions to it and attaching to it how they can make and perform as per the industry requirements of today. Let us list out a couple of limitations that we see. First of all, the basic limitation is these machines were using old hardware or processors which are not scalable as of now. The cost of maintenance is also very high because these processors and hardware require a lot of maintenance and we have to have a lot of space in our house. Speeds were low. Machines which were working on manual intervention because operator need to intervene and do a lot of job changes, setting of the tools and so many other things which cause the efficiency of the machine to go down. they were difficult to integrate to a level. Efficiency was compromised, safety was compromised. As a result, we had to do a lot of manual checks to the component that were being manufactured. Now, considering the demand of the industry today, we want them to overcome these limitations. And how do we do it? One of the most important aspects is to involve or use sensors to the field. Now, we all would agree that sensors are the key elements of a control system. They are the building blocks, and they help you to build a system which can further be improved. Not only is the productivity or the efficiency of the machine depends on the type of the sensor that we use, but it also improves the preventive and predictive maintenance of the machine. Because today we have smart sensors in the field, which can not only provide you the diagnostic parameters as well as the service parameters. So based on those diagnostic parameters, we can control the whole system and improve it further. Data is also an important aspect which is involved, and we can get a lot of information from these sensors if they are employed properly in the line. Operator safety is also an important concern with these type of safety machines or legacy machines. So safety can be improved by adding a safety solutions to the machine. So over the last couple of decades, what we have seen is the sensor and sensing technologies have improved vastly. Right? The sensors which we use today are becoming more and more fast, more and more responsive. That means the speed with which the sensor responds back is higher. The reliability and the precision with which it senses the target is also improved a lot. And not only that, these sensors have become more repeatable. That means if you are measuring something, you are getting the same values over and over again. And that is what is the need of the hour. Looking at the housing of the sensors, these sensors are more rugged because we come from different industries, and different industries have different industry standards. So as to meet to those standards, we have rugged housings, serviceable, and most of all, it is interoperable because we have different type of controllers, different type of PLCs, different type of embedded systems which are used. So we have to have sensors which can be connectable to either of these situations. And lastly, which is most important factor is these sensors should be plug and play. Means I should not waste my time connecting a sensor to a machine, whereas it could be an easy plug and play system. So now, since these sensors are becoming smart, so these sensors can be deployed into a legacy machine to make it more smarter. And how do we do it? There are different type of solutions which are available, right? Areas of application which can be directly implemented into a machine to make it smarter. Detection systems, sorry. Just a second, please. नमन
एक मिनट रुकिए कि वो स्क्रीन का डुप्लीकेट करने का इशू
डुप्लीकेट से पहले हो गया ना ये
से जाएगा
कंट्रोल
हाँ इसको डुप्लीकेट कर दीजिए और प्रेजेंटेशन मोड से बाहर ले लीजिएगा
वहाँ से होगा सर
should not have इसका स्लाइड शो यहाँ से एंड कर दीजिए ये तो सही चल रहा था मेरे केस में मेरी लैपटॉप की स्क्रीन ब्लैंक हुई थी
आपकी हुई थी
हाँ मेरी तो लैपटॉप की स्क्रीन ब्लैंक हो गई थी
नहीं दिस इज फाइन
डुप्लीकेट कर लीजिए कुछ नीचे जाएगा फॉल्ट
वहाँ से तो निकला
बुला रहे भेजा बंदा सर आप मुझे बताइएगा मैं कर रहा था नीचे से कुछ और फॉल्ट तो नहीं
नीचे एक बार वैसे डिस्कनेक्ट कर देना ओके दिस वे
नेटवर्क का इशू होगा नेटवर्क का इशू होगा ये सारा कनेक्टेड नेटवर्क पे है नेटवर्क लाइट हो रखी है से ठीक है, नेटवर्क लाइट रेड हो गया, नेटवर्क गया क्या?
हो जाएगा अभी। नेटवर्क है।
भाई इसको परमानेंट फिक्स करो, ये दोबारा नहीं होना चाहिए।
क्या हो गया?
लैंड वायर इशू। लाइट क्लीन नहीं हो रही ना, तब तक नहीं चलेगा। We apologize for the inconvenience.
हेलो, व्हाट्सअप कॉल करो, व्हाट्सअप कॉल।
वीजे केबल है।
हेलो सर, इधर लाइन केबल में ना ग्रीन लाइट नहीं आ रही, दो बार निकाल के लगा दी।
उससे क्या फ़र्क पड़ता है?
सर एक बार लैपटॉप दूसरा देना।
आपके में है शायद कॉपी।
हाँ मेरे पास कॉपी है।
लाइन किसकी में जाएगी? लैपटॉप पे थोड़ी लगा हुआ।
लैपटॉप दूसरा दे दीजिए।
दूसरा लैपटॉप में चेक कर लो यार। लैपटॉप से कोई इशू होना नहीं चाहिए ना।
नहीं, वो लाइन कह रहे हैं नीचे।
नहीं। We are sorry for the inconvenience. It will take some time.
लाइन ब्रेक हो गई। ब्रेक मत, लाइन ब्रेक मार लीजिए।
येलो लाइट जल रही, ग्रीन ऊपर से एक बार चेंज करके
लाइन केबल दूसरी चाहिए हो गया।
लैपटॉप ऊपर लगा दें तो चलेगा।
चल जाएगा। फिर यहाँ से चेंज कैसे कर सकते हैं? पॉइंटर से आपको बोल के। ठीक है, फिर वो करवा दीजिए।
वीडियो क्लिक करा दीजिए।
या तो ऊपर लगा दीजिए।
ऊपर वाले तो नीचे बैठे हुए हैं।
लगाइए।
देख लेते हैं सर, नॉट विदाउट इन 2 minutes तो विल डू दैट। ऊपर वाले यहाँ हैं। डुप्लीकेट है। कोई VGA या HDMI केबल अलग से है ऐसे जिसको लगा सकें?
ऊपर ही लगा दो, वो बेटर रहेगा।
लैपटॉप ले जाओ, डिस्प्ले कर देना। कंट्रोल कैसे करेंगे? पॉइंटर
किसी नहीं रहना।
एक सिग्नल आ तो गया ऊपर से, एक बार चेक कर।
पर परमानेंट रहेगा या फिर चलाना जाए?
ना ना
सिग्नल तो आ गया, ग्रीन हो गया ना। उसको ठीक से अंदर कर दो बॉक्स को। ये केबल निकला हुआ किसका?
वो दूसरी केबल।
ऊपर कोई है?
ऊपर तो आ रही है स्क्रीन।
ऊपर आ रही है?
ऊपर आ
लगाओ
रही है।
यार, ऊपर से इसको लेके जाओ।
नहीं नहीं इसी से यहीं से आ रही है ऊपर। एक मिनट।
अच्छा, ऊपर यहाँ से? तो फिर क्या
यहाँ यहाँ नहीं आ रही।
तो फिर ऊपर से भी नहीं आएगी नीचे?
आएगी आएगी, एक मिनट वो चेक कर लें। लैपटॉप लैपटॉप
मैं लगाऊँ अपना इधर कुछ करने के लिए?
राहुल, मैं पॉइंटर ला के दे दो सर को पकड़ा देना, ठीक है?
मेरा लैपटॉप चाहिए होगा ना आपको फिर ऊपर?
अच्छा, आपको लगना है? हाँ हाँ दे दो, आप दे दो।
उस लाइट से चालू कर देना आप।
हाँ ठीक
ठीक है।
ठीक।
क्या मैं अपने किसी को भेज दूँ या पॉइंटर आप चेंज कर लोगे?
मैं पॉइंटर दे रहा हूँ मैं आपको।
ठीक है, तो ये हटा देंगे ना हम? Good. Pointer. ऊपर नहीं है, लैपटॉप वहाँ पे है. यहाँ से हो जाएगा ना? एक सेकेंड. Okay. Oh, good. Sorry for the inconvenience. So let me start from where I was, what I was talking about. So there are a lot of applications or that can be implemented into a legacy machine to make it more smarter. एक वो भी शेयर हटा दीजिएगा please. Okay, something like a detection system, which is sensing solutions. Measurement, because most of the operations which are being done in the machine are done manually and they require a certain level of measurements to be done. So measurement systems could be one which can be implemented. Similarly, positioning systems, identification systems, evaluation, quality checks, plus making the machine more smarter by interacting, by connecting with them so that you can extract a lot of information from them. So these are different type of solutions which you can implement into a machine and extract all the information which is required by you. Let us talk about how the technology got developed and how we can do a detection along with measurement using a simple inductive sensor. Now, inductive sensors basically work on a simple concept. They have a coil inside it and they measure the presence of metal target in front of it. Now, if you put multiple coils inside a sensor and put a metal target which is moving parallel to it, you can not only do detection, but you can also do measurement. So in a lot of legacy machines, we have to make sure that the tools are aligned properly or how much the tool have to travel. So for that, we require measurement as a solution. And this could be one which could easily solve those type of solutions. Using a simple concept of an inductive sensor, but giving you not only sensing, but also measurement. Lot of areas which we see in the industry today are like machine and operators are working together, and it is very important that the safety of the operators are maintained. Not only that, safety, if it's compromised, can cause a lot of accidents, which is not required. So how do we do it? Wide variety of solutions. If you are working on a press, safety light curtains could be one. If there's a robotic cell, you can have a lidar, which is a safety-based lidar. Also, for access control, there are ultrasonic sensors, which are again on safety, which can solve most of the safety-related issues. Lifting areas where you have a component which has to be lifted to a certain height, it has to be ensured that the component is properly clamped. For sensing of proper clamping, inductive sensors with safety certifications play an important role. There are a lot of applications in the industry where quality has to be improved. Like we have to check the quality of the product which is being manufactured. And there are certain quality parameters which have to be checked. Optical gauging is one where we need to measure the dimensions of the product, whether there is a groove inside it, whether there is a hole with the diameter of the product which has to be measured, to read the optical characters on the product, to do the profile checking of the object. So what is being done in the industry today, which are manual operations, they use a lot of gauging tools. They use a lot of manual inspections. All these systems can now be automated by installing vision systems into a machine. Now, if we talk about vision, it can make quality checks easier, much more faster, and much more preciser. Different type of vision systems can solve those problems. These are various varieties. For example, a normal vision system, which we have normally used, a smart camera. A camera consists of an image processor, which captures the image of the object, breaks the image into small pixels, and based on the small pixels, you do the evaluation, whether the component which is manufactured is as per the required standards, and if there is a small defect, it can be easily distinguished. These are the conventional cameras. I think most of you must have seen, must have used, must have already as they're existing. What is new is this, that these cameras which are working on X and Y, that means it can only measure 2D in terms of X and Y axis. But we have to check the profile of the components. Those are another important aspect. And for that, there are profile checkers which work on X and Z axis. That means they measure the depth of the object which is there for profiling. And similarly, there are now vision cameras which work in all the three axes, that is X, Y, and Z. So they do a 3D measurement of the object. This type of systems consist of two different cameras installed into a single housing. Both the cameras capture two images of the object, which are 2D object images. These two images are then joined together or superimposed with each other to form a 3D image. And this 3D image becomes a point cloud. And based on that, you can easily detect a defect in the component. You can do the checking of the component. You can measure the dimensions of the component. So a lot of applications which were annually done earlier can now be solved using a vision system. So whether it's an X and Y vision or X and Z or an X, Y, and Z can solve a lot of these applications. So again, cameras come with different options, different accessories, different lenses, different lights. It can be integrated. Sometimes it's inbuilt. Again, this is a simple example of a robotic cell. Inside a robotic cell, what we do, we have a welding line, right? There's a mother component, and on top of a mother component, you have to weld a small child component. Picture below shows you. This picture shows you the color of the component. The mother component and the child component are of same color, same texture, same contour. And it becomes very difficult to detect this type of child component, whether they're present or not. Profile sensors will have a different profile where when the child is absent, it will have a different profile with the child present. So based on that, you can easily distinguish the presence or absence of a child component on a mother component. Like I said, 3D cameras are again an important aspect. They can do the 3D imaging of the object, and based on the 3D model that you have, you can easily check for dimensions, defects which are available. Another type of systems or solutions or applications that we see in the legacy machines are related to positioning. Where to pick, what to pick, how to load, how precisely to load, what are the accuracies that we require, and how much about the repeatability. So these are some of the important aspects. Whether you have an overhead gantry crane, which is supposed to pick and place a component from one point to the other with a high accuracy, whether it's a galvanizing plant where you have a dipping systems where the transporter needs to be positioned just below the tank so that it can do the dipping properly, whether it's positioning of an AGV, which is moving on a flow, or a skid, which is carrying a car body on an EMS conveyor or a floor conveyor. So all these type of applications require different positioning. Pick and place is one of the important aspects. So these type of systems can easily be automated by using a small, simple concept of positional systems, like a normal absolute encoder could be one of the solutions, or an optical rail-based system where we have an optical rail with a read head which is moving on the component. As the component moves on the rail, you get absolute positioning with an accuracy of 0.1 mm. And with that high accuracies, you can pinpoint the position of the object, do a certain operation on it, and then it can move on to the next location. And these systems, since they are based on absolute positioning, you always have the same values in case of a power failure. The speed with which a positioning system can move is up to 12 meters per second. So at high speed, you are doing absolute positioning with a higher resolution, and a lot of operations can be easily done. The latest trend which has happened now is, instead of rail-based, which was a mechanical-based system, there are now optical-based systems where there is a camera. The camera decodes the barcode and then gives you the position. So most of the EMS conveyors or most of the overhead conveyors are now going into this type of solutions for absolute positioning. Right? like I said, identification of tools, identification of job, identification of the components which are being manufactured is also another important aspect in the line. Tracking and tracing, to know what product was manufactured, what was the genealogy of the product, what all features, what all parameters, or what all the processes that the product went through before the final product was manufactured is also to be recorded and traced, right? And for that, identification system, whether it's a barcode-based system or whether it's a radio frequency-based systems, are widely used. So in this concept, in a legacy machine, we have to identify the type of tool or identify the type of job. So all these devices can be tagged. You can have a tag attached to a job, and based on the job, you can select the right type of a tool by attaching a tag to it. So automatic tool selection based on the job can also be done using an RFID-based system. RFID systems have now increased or improved a lot, where there are now different frequencies. Earlier, it was just limited to short range. Now there are systems which can go up to longer ranges, which we call as a UHF frequency tags. You must have seen toll collections. That's the frequency of, that's the UHF readers or UHF tags that are being used. It allows you longer read range, passive tags because they don't have a battery inside it, plus they can be fitted into any type of an equipment because these tags come in different form factors and allow you to read different type of allow you to read and write what all information onto it. So gone are the days when there was a job cart which was moving along with a component from one station to the next station. Now all that information can be stored inside the tag, and at the end of the line, all those information can be extracted and then taken out to the server or to be connected to the ERP system directly. And once required, it can be retrieved directly from the system. There is a new trend which has come up when it comes to identification system. There is a new standard which is coming up, which is known as OMLOG standard. Now, this standard allows you to do digitization of supply chain. In a warehouse, I may have a lot of components which are placed at different locations. And these components to be identified, we need to identify the location. That is real-time tracking of the product. So OMLOG standards allow us to identify the object, at which point it is, at which location it is, and we can do the geomapping of the area using this standard. So this standard now connects 5G technologies, GPS systems, ultra-wideband, Bluetooth, and bring them all together onto a same platform so that it can be connected and all that information can be taken out. Okay, like I said, one of the major aspect is from a legacy machine is to take out the information from it. And what type of information do we require generally? We require cycle time, cycle count, uptime, downtime of a machine. We require diagnostic data, whether the machine or the sensor is working perfectly fine or not. Plus, we require defect rates. So all these parameters can be extracted from a legacy machine. There are different ways of doing it. Some of the simplest way is to add a PLC on the top. Now the PLC allows you to give you both production and process data. Simpler way would be to add a sensor to it, but a sensor will only give you a process value. It will not help you with the further parameters. So there are smart sensors which are based on IO-Link technology, which allows you to get not only the production data, the process data, plus you can do diagnostics, which will help you to do preventive maintenance, as well as parameterization. A lot of times we have seen there are machines which are working, which requires a lot of parameters of the machine to be changed. Because the job changes, we have to do the adjustment of the sensors accordingly. Sitting at remote locations, this is possible now. So what this technology does, or what this system brings into the industry is that now you can do parameter setting of the machine, of the sensor sitting remotely. That means you have a sensor which is supposed to work on a particular machine with a particular job. It has to be adjusted accordingly. And if you change the job, generally what we do is we go to the machine, we change the position of the sensor. But now we can retune the sensor sitting at a remote location. That is what we call as automatic parameter setting of the machine. Secondly, another thing which we can extract is we get both process and service data, right? So whatever is the process value is going into for the controlling purpose, but service data is also available, which allows you to do a lot of diagnostics of it. Simpler example, you have used an inductive sensor, right? An inductive sensor is supposed to sense a presence of a metal target. Now, due to vibration on the machine, the screw gets loosened out. As a result of that, the position of the inductive sensor shifts. Now, if the sensor is able to generate an alarm to tell the operator that there is a position shift and I have to retune it, so that will be a helpful event to predict the downtime or reduce the downtime. So this technology, which is an IO link, which is inbuilt into the sensors, allows you to do all this. If there is a position shift of the sensor, immediately an alarm is raised, and based on that alarm, you can do preventive maintenance easily and quickly. So this technology is not just limited to high-end sensors. It's available in basic sensors, whether it's a photo sensor, a light curtain, or a light grid, encoders, vibration sensors, temperature, pressure, flow, whatever you name it. All these products are now available with this technology inbuilt into it. This was an association which started or built an IO-Link technology which was inbuilt into all these sensors. Now, condition monitoring is also an important aspect. We need to check whether the machine is performing as per the requirement or not. Whether there is a vibration in the system, because of the vibration, there is a wear and tear of the machine, and which causes a lot of downtime. So a normal vibration sensor can be connected, and you can have a dashboard where you can see the process values, where you can store the historical trends, and then retrieve it. And in case the vibration goes beyond a certain limit, it can be immediately captured, and the machine can be immediately stopped for the maintenance work. So vibration sensors, temperature sensors, flow sensors, all together can work for a condition monitoring of a normal legacy machine. Moving on to the last part, since we were talking about connecting, now it's possible that we can connect all these field sensors not directly to the PLC, but directly to the cloud using a master product, which is an edge gateway device, which allows you to transfer the information either to the PLC or directly to the cloud, wherein you can take it on your smart device and change the parameters. So OPC is one of those latest trends which have come up in the industry. The biggest benefit is it's vendor independent, it's platform independent, and it's programming language independent. Because generally, if you work on PLC, you have to have a certain programming software to program that PLC. But OPC UA allows you to use any programming language, whether it's .NET, C#, whatever. Platform independent means you can have a Windows-based system, you can have a Linux-based system to control it, and it's not a product, it's a technology which allows you to control sensors and other field devices to communicate directly with the cloud or with the ERP systems. So this was what I wanted to present. Thank you for your patience listening, and hope it was informative to you. Thank you so much.
Okay, I think Naman is upstairs. Can I now request the second speaker, Mr. Vishwanath Chari, to come? His presentation will be based on a video sharing. So I think you'd like to start first and then have the video.
Yes.
Okay, please start.
Good morning, everyone. Thanks to AIA to actually organize this event, and thanks to Mr. Wadhwa, Mitsubishi team, and all dignitaries in this event of smart manufacturing for enabling competitors. Am I audible to all? Yeah. So you will play the video from there. Okay.
Just give me a sign. I'll immediately.
Sure, sure. So, Mr. Wadhwa has already set a context like, data is something nowadays actually disrupting our, day-to-day life, In last 10 years, lot of things has happened like, the way Ola and Uber has disrupted our mobility requirements, right? And if you see the new ways of mobility, like particularly in EV segment, that is also coming up. Similarly, in manufacturing, the way we were actually working in last 30, 40 years, that is also getting changed by by enabling manufacturing operations smarter actually. So, smart was already implies like anything which we are doing actually has to be measurable, and giving some results, right? So here, when we are actually getting some data from our processes or the human operations, okay, so that is something bringing intelligence on top of that, and that too we are actually linking with our business KPIs or the results outcome which we are focusing on, right? So that's how Industry 4.0 is actually focusing on, and we at Hero MotoCorp also embracing the same technology. And Mr. Sudhanshu has already talked about a lot of things, particularly into this domain. He's talked about a lot of sensors which are actually enabling legacy systems more smarter. So that is what we guys have also done, and how our journey embraces the Industry 4.0 and bringing intelligence, wherein now how we have changed the way we are working earlier and now how we are working in our operations. We have seen one of the example where our dignitaries have just lamp on the light through digital medium. So that is what the wow experience we already have. So that is something we are also enriching our employee experience as well as the customer experience. That is what our focus area nowadays at Hero MotoCorp. And more importantly, everybody is actually looking for a business value, a significant business value actually, and that is what data is a new oil actually, and it is really bringing a lot of change, and in terms of ROI, there is a lot of opportunity that is actually coming up. So, we have prepared one success story. It's a small success story, but yes, a huge amount of work has been done by a team, collaborating with our cross-functional team of operations, and of course, our business leads also supported us in getting done that particular, solution. So, I would request to actually run that AV for everyone, like what great work we have done, and that too also in progress at Hero MotoCorp. Can we have audio, please? Audio is not there. efforts will go waste. Then I guess there is an issue with the cable, I guess. Otherwise, I would have done. What is this channel? Testing, I guess. Yes. Where's your mic? Here it is.
And we are in the midst of a significant digital transformation regarding the way we produce products or enhance customer or employee experiences to meet changing business and market requirements thanks to the digitalization in manufacturing. This transition is called Industry 4.0 and represents the fourth revolution, the cyber-physical system, that has occurred in manufacturing. We started digital transformation journey much
This
before
breakdown
when
is
other companies were just thinking.
a good
The key
indicator of what will be
objective is
the
to
challenge
enable
when
factory of
we want to
future
connect
to
the
drive
whole cyber
manufacturing
system to the
forward,
physical
to be
shop floor.
faster, more
Yeah.
efficient and customer-centric. One of the keys and complex operation area in the plant is utility operation, which also contributes to major manufacturing cost. Current utility operations are highly person-dependent, complex and widely spread across the plants in acres of land and take a huge amount of time and man efforts to monitor and operate the utilities at remote locations and doing routine maintenance checks every day 24/7. The scope considered for utility cockpit is for 7 areas. Those areas are ETP effluent treatment plant, STP sewage treatment plant, WTP water treatment plant, MEE multiple effect evaporation system, HWG hot water generation, RO filter plant, fire pump, compressor house, energy substation, remote location bore wells, and at consumption aluminum phase, steel phase, engine assembly, frame assembly, paint shop and weld shop. There are 750 unique monitoring points for utility health. There are 36 critical equipment controls points. There are 90 condition-based monitoring (CBM) parameters for real-time alert and notification and action. There are 31 utility real-time utility KPI for all 7 areas for engineers and their managers for performing immediate action for resource optimization. There is a mobile application for these 7 areas for engineers and managers for taking real-time action. Utility Cockpit application is integrated with SAP for actionable insight reports and dashboard. Utility Cockpit application is also integrated with Gmail and SMS gateway for real-time email alerts and mobile notification. Outcome of Utility Cockpit: elimination of logbook by reliable automated data collection for analysis. Elimination of manual data records and redundant activity. Elimination of check sheets for real-time monitoring with set control limits. Elimination of Excel working for reports, check sheets and data entry into SAP. No manual equipment control. Defining baseline on resource losses and doing continuous improvement by taking real-time action on resource optimization resources, from the visibility on resource losses and predictive maintenance, with analysis, improving the life of machinery.
So this is what one of the success story which I would like to showcase here. And if you can see, like, we actually focus on the major business problem which we are actually focusing on. Our goal is to actually optimize the power consumption by 10% what we are consuming. So we are actually producing in a year 70-75 lakhs units in a year, and our manufacturing very well goes per unit, that is something around 350 rupees. So huge amount of the cost which basically that goes into these particular utility areas, and that too a lot of manpower which get involved in managing these utility operations. So, our focus was to create a new operating model and, remove all those NVAs, how we can actually, right from the layer one, where actually the small equipments and their data actually creating some insights. So that was the detailed working we guys have done, and, the how to connect with the enterprise application, how to modernize our operations. That was the overall focus area, right? And we have created one of the lighthouse in our greenfield factories, where this was work we have done for utilities, but for machine shops and our paint shops areas, where we have digitalized the entire operations, right? So I believe, data is something, definitely it actually ignites something, but bringing intelligence on top of that data, that really makes a difference for bringing the manufacturing competence and benchmarking into the market. Thank you, everyone.
Thanks for the presentation and apologies for the glitch. Now I would like to invite Mr. Sunil Mehta to come and take a seat on the sofa. He will take the discussion forward along with his opening remarks. So meanwhile, can we also request the previous speakers to come on this stage and join? Over to you, Mr. Mehta.
Yeah. Good morning and thank you for joining us today. Already in the morning we had two sessions, and I think PNF and Hero MotoCorp, they briefed about connectivity of the legacy machines. So the topic of today's discussion right now is connectivity of legacy machines. My introduction is already been done. I was a part of Messung System. We were indigenous PLC manufacturers, and Mitsubishi took over us in year 2012. So since then we are a part of Mitsubishi Electric India. When we talk about legacy machines, we as a Mitsubishi Electric India, we have developed low-cost automations. We have a lot of products which are available for connecting all the old machines. We call it a GOC, and proud to say that this product is designed and developed in India and Pune, and we are exporting to European countries also as of now. Now when we talk about Industry 4.0 or smart manufacturing, I don't know whether how much Germany is really has done Industry 4.0 in real sense in Germany itself, but in India, after COVID, I think a lot of journey has happened, a lot of things has happened. We as a Mitsubishi Electric, we coined terminology called as e-factory, and that concept was introduced way back in year 2003 in Japan. So when we say e-factory or when we say Industry 4.0, we just say that connectivity of those machines to the ERP system or to SAP or to Oracle database and all these things. So as we have got a lot of sensors and old machines in India, there are many plants, SMEs or MSMEs, where a lot of machines are working with the relay logics, with the old PLCs, and it's very difficult to connect those machines to the latest systems, where we talk about OPC UAs or we talk about a lot of protocols, Profi, CC, EIPs and all these things. So many of the controllers does not support that. So a lot of low-cost automations are available, sensors are available. So those connectivities are definitely possible. So with this remark, maybe I would like to see that more interactions from the audience, because I know that a lot of industries people have came here, academia. IIT Institute is one of the premier IIT Delhi. In fact, we are all sitting in IIT Delhi. That's a really good thing. And I'm also part of Foundation for Smart Manufacturing and AIA. So we do a lot of interactions with the academia. So we want to bridge a gap between industry and universities and academia. So that's also one of the motive where Anup Advaji and we are working on that. So thanks for joining, and I would prefer if you have the questions for the speakers, which has already been done. I don't have any presentation, but I have rich experience of 35 years in automation industry. So we are available here to discuss more about automation, legacy machines and these things. Anybody would like to have any questions? so that we can take this discussion forward. I'll prefer active interactions. People are from Maruti, people are from Hero MotoCorp, Dixon. I can see the people from integrators and all these things. So it is better that we have, we would like to have your inputs or maybe your questions for this. People talk about ROI, people talk about Industry 4.0 protocols, 5G technologies, standardization, so many things. Energy savings. So all these things are there, and industry experts are available across in this forum. So it will be better if we really get something from academia or students or whoever want to discuss. So I would like to open the discussions. So if there are no questions, then we say that whatever we have spoke about is everything is. Yes, sir. Pardon?
If there is a machine with the old controller and has no communication port,
Right.
how we can modify that? How we can get the data from that?
Yeah, that's why the first presentation we have a lot of sensors available. Maybe vibration sensors, temperature. So we take those sensors. One of our company, eFactory, yeah. Maybe we need not have to interface with the controller. It's the sensors will be interface directly to the IoT gateways, or it can be directly connected to the. What we do typically in Maruti and Hondas and all these things, we've done a lot of jobs. What we do is that maybe we make one small PLC for 5 to 10 machines. So we make one control panel, and that control panel takes data from at least 5 to 10 machines, and that small PLC gets connected to the IoT gateway or the upper layer. So that we say data concentrator or something like that. And today the PLCs the memories has increased a lot. Like we have seen a revolution of mobiles. We talk about 64 GB, 128 GB iPhone and all these things. Similar way with PLCs, we have huge memories available within PLC. So we have small PLC of very less IOs, but with a good memory, and it gets connected to all the 10 machines in that area. There is one eFactory Alliance partner in Pune. They do a lot of job for us for injection molding machines. Now injection molding machine, you can imagine, Prince Plastics and so many people, they have got so many machines with the different controllers. DGP Windsor and so many. And all these things, those machines, they may not install, they may not connect to the controller, but then they get the machine data directly from the machine. Because you need mold open, mold close, you need how many jobs has been done, that's it. So that can be done, temperature and all these things. So some specific parameters we pick up, we don't touch to the controller, which is legacy controller. Companies like Mahindra's and Tata Motors and all these things where we have worked, where they phase-wise they go for the replacement of the PLCs. So that is also possible. But it depends upon what exactly you are looking for. If your shop floor has got 10 machines and all are dedicated controllers, it is better to have a small PLC and sensors connected to it. Yes, sir.
Actually, my question is to that how we can integrate all these things to a function where production it's not directly related to product. Hello. Yeah, actually my question is to the entire panel member, all these panel members, that how we can integrate this technology to a function where which is not directly related to production but indirectly, like a lab function where you have handhold where you have to handhold a lot of data, and each and every equipment has their own segment. Like there are equipments which gives you data in form of image. There are few equipments which give you data in form of some readings, or something is to be interpreted out of those images. So how we can integrate all these things into a system which can help in running a lab or handling the data which we get from a lab. Okay, so any thought or any idea on that?
So basically, you touch upon the quality function, right? And quality is something which is actually heart of any product, right? So, integrating quality systems, right? And that too with your product, that is what very important, right? So basically, if you have a right use case in place, for example, the product which is running on a line or which you are actually processing, so you have to first clearly identify what all your critical process and critical to quality parameters that you are focusing on, because in your standard room you are actually checking your product on sampling basis, right? And your quality inspectors who are deputed on the shop floor as well as the production guy, okay, they are actually looking on your reports, right? Because your outcome which actually tells about the product which they are making. So here, if you have a right strategy in terms of use case which is integrating your let's say a CMM machine or other quality labs instrument like hardness tester or other instruments which actually connecting them the results, okay, which is they are making on the shop floor, will really help them to take the decision in real time, okay, which you guys can avoid the rejection basically which is happening on the line. So basically integrating independent system, I would say change that particular strategy, because doing something in silos will not really yield any benefit to you in terms of business value, right? And of course in terms of standardizing your processes also. So you first plan something which is actually integrating your shop floor along with your standard rooms or the all those systems or the process which you are doing, okay, and start integrating this system will really help you to monitor what is happening on the line as well as the product which is coming in your standard room, okay, what results you are getting, so that you both as a team can collaborate and get the same results on the real time. So integrating is something which is actually standardizing both the systems. So as Mr. Sudhanshu has already talked about gateway technology, we called it as a edge computing something, right? So that in fact you can also embrace, right? And then for decision insights and building those MIS reports, something you can in fact embrace cloud, okay, for those dashboard reports, right? So collaboration is a key actually over here, right? And define a proper use case, because data kept in silos, like I've shown my utility use case. We did a lot of work in Excel working and preparing an MIS. So we have 7-8 areas and independent areas are working in silos, okay. The collaboration was the gap which we identified, and we have integrated with the kind of a platform which we have built. That is what now everyone is having a kind of an insight, same insight basically, whether it is a consumption side or it is a generation side. So I would say integration is something which now technology has already enabled, right? So you guys first place in a use case wherein your shop floor guys can collaborate with you, okay, and then focus on the quality piece. That is what CPCPK or the first time right was the KPI for all of us to actually get the product developed first time right. So that is what you guys can focus on.
Thank you very much, sir. Actually, what I was looking for was how we can change or how we can implement all these things in a lab function, because we do interact with our shop floor guys, but that interaction happens through a certain system. But what all testings we do, okay, how at what level we are monitoring the incoming samples at a fix or what if there is a case which needs to be investigated, how we are handling that, how that data we are producing, where we are storing, that part is taken care of. But how we are engaging our machines and how we are utilizing our resources at a skill level, at a part level, and at a machine level, okay, so that what I was looking for.
So again, when Mr. Sudhanshu has talked about some RFID sensors, right? So that is something, a piece of information definitely from the machine and equipment which is having a kind of a specific information linked into that, right? And the vision system also. So that to really help you actually.
Yeah, of course. Like there are so many systems that can be deployed. So depending upon the problem area, we can have a system, and from that system which is deployed, you can take that information to the centralized system, and where you can have those reporting as per your requirement. So you can have a small customized software which can help you to get those information which are most relevant to you rather than the whole area.
So actually the challenge which we, good morning to all. Thank you so much for your presentation. Actually it was very insightful. The challenge which we face is there are some machines which are having PLC. So getting data out of that is very easy. We can do that very easily, right? But there are few machines which are very old, like already you explained, legacy machines. There is no way you can connect anything to get data out, right? And the machine maker is also not ready to allow you to do any modification over the machine. So are we having any system by which we are not damaging that particular machine, or we are not impacting the software, and we can fetch the data without getting into that system, right? So are we having any such sensor? And second thing which I will be interested in knowing about UHF. You explained about the RFID. It is having a 6-meter range, right? Which we are having in our vehicles also. So what is the costing structure? Because what I want is, in our industry we are having lot of places where we are having a lot of scanning, QR code scanning. So I want to remove that particular step, because if RFID is commercially feasible, viable, right? So let us go into that so that I can reduce my manpower effort, right? So I want to know on this. Thank you.
Let me answer your first query. Where you wanted, like you have certain machines which have a dedicated controller and you cannot do anything with those controllers. What we can do is, we have to understand what we want, what all information that we want. Now whether we can connect a couple of sensors, or there are some electrical signals which are there in the machine itself, that can be parallelly mapped onto a edge gateway or a IO-Link master as such. And from those devices, you can take that information to your centralized server and do whatever you want to do. So easiest way would be to look into that machine to take some electrical signals. Like if I want a quality to be done, I can have an independent vision system which can do the quality check, and all those information, whether the quality has passed or failed, what were the parameters, whether it's dimension checking, all those parameters can be taken directly to a PC-based system without any addition of a controller. Now, if there are certain small equipment or small defects that has to be checked, you can always have a sensor to it, and that can also be connected. So there are different ways of doing it. Now depends on what type of application, what type of machine, and what type of information that we are extracting from that device. Coming to your second query where you asked about the UHF technology. See, like earlier technologies which were working on HF and LF, they had a different form factor of tags. UHF is a technology which allows you to have passive tags, and these passive tags are, if ordered in huge quantities, can go up to as low as 2 or 3 rupees per piece, right? And it all depends whether the product which you are manufacturing, that tag will go along with that product. If it has to be reused again, then it's no use of going with a solution like that. But if it can go along with that, you have to have a low-cost product, and UHF technology now allows us to have very low-cost tags in a form of a sticker which can be just pasted on the product, and it can go along with the product out of the factory directly.
Suppose if we want to put that tag on a bin, so we are having a binning system.
Yeah.
So we are having a binning system. On those bins, we are placing the samples, right, for testing.
Yeah. Yes.
I want to reuse it multiple times.
Of course.
Okay. So what exactly the type of RFID tag I should use?
So there are different form factors, like what bin you are having. There are small plastic tags, there are small rubber tags, there are certain tags which can be embedded into the plastic directly. They can be screwed into that plastic bins. So there are different form factors. So depending on the usability or what all information you want to write, how much is the information that you want to extract, you can select either of the tags. Yeah.
Okay, can I just suggest that on this topic of making legacy machines smart, we will also show you a 1-2 minute video of what we have done here on the premises, and in the afternoon you will take a tour there. You will get much more ideas how we have been able to convert a lathe machine, how we have been able to take data from a CNC machine. This discussion is very interesting. If we could have had a 1 hour session, I'm sure that will also do justice, but other teams are waiting. So if there are any more questions, make them very brief, and we would then like to move to the next session.
I think I think we can take the last question, if the time permits. No, sir. Good morning, all. So I am Nitin Yadav from Maruti Suzuki. So I have one question in general. For example, if we talk about the OEM or the tier ones, then most of the things are getting done easily. But since our most of the manufacturing is being done at tier 2, so there we face the challenges in the implementation of this smart factory concept or the automation concept. So for example, I will specifically ask about the injection molding shops. So there we encounter this problem that we want the suppliers to implement the technology so that they can sense, for example, the cycle time or the injection pressure, injection temperature, mold temperature, whether their chiller is working or not working, what is the downtime or what is the vibration that is there in the sensor, because they have a huge downtime also. So there at tier 2s, we focus, we encounter this problem of the cost. They say that we check with the solution providers, but it is too costly. And that is why they are not able to purchase the new machines also, and they are not able to convert their existing machines also. So what are the types of low automation and how these tier 2s, which are the heart of the manufacturing, they can be upgraded?
See, your question is correct. But what is happening is that the companies like Maruti or Honda and these things, they are now handholding tier 1 and tier 2. So that is already happening. And second point is that if you talk about specifically injection molding machines or these type of shops, low-cost solutions are available, including the softwares and including the hardwares. So we need to study that and we need to really give the proposals. It's not like that they have to go for very expensive solutions or something like that. But there are very good companies, and we have some IT partners who have focused on injection molding machine areas, and they are doing a very good jobs across India. So we can work it out and we can really look into your requirements. So that is possible. Maybe I can take last one question because he was, yes, sir. Yes, please.
I'm just curious to understand if there are published case studies that one could refer to, say, for example, from a point of view of savings from power or energy in general, from savings from maintenance, etc. So if we could take any particular setup, that would be very useful, because I represent sort of the sustainability side of business, and there is a lot of applications that we are seeing in companies trying to drive their net zero targets, and automation is a very big feature in that, which is also apparently cost saving. And the second part to this is that in greenfield versus brownfield projects, which is legacy versus new implementations, typically from sensorization and automation, what is there a difference in performance that we see, and if so, what's the delta typically?
Wow, really tough. See, the first question is all depend upon the policies like Maruti and Honda they adopt, because I don't know whether they really publish the data or not. Ideally, how much energy is saved or something like that, it's finally the company policy. Because we have done a lot of jobs in even two-wheeler and four-wheeler plants where we have done a lot of energy savings. But that data is available, and that data is available within the company. We as a automation supplier, we are not allowed to disclose anything. But it all depends upon those companies if they are willing to disclose that data, and usually they should do that. It's not a big big deal. I don't know whether Hero MotoCorp disclose the data.
So I've disclosed some of the high-level figures, right? But I would just simply say, if you guys are doing something, right? If you are working on a pilot, okay, and the key is like with your key end users, if you can define one of the KPI, right? Any one of, like for example, in case of maintenance, MTTR and MTVF, right? You just define that, okay? And just focusing on that KPI, look at all those aspects where the equipment inputs, basically, those are the specific phenomena causing the breakdowns of the equipment. That in fact you can vouch for, right? For example, there are 20 phenomena which are really impacting the equipment utilization, right? And that's where you will actually get the key, right? And from there, your team will get a confidence. And definitely it depends on sector to sector. For example, our is automotive. In process industry, the operations are different. So definitely the potential which you are actually focusing for, let's say, in our case, the potential is not more than 5 to 6%, right? But that too also we are getting churned out by doing CBM and PDM also. So it's completely vary. Last year, from one of our factory, we saved 640 tons of CO2 by just optimizing KWH consumption, right? So that is what it totally depends, like what kind of operations are there, how much manual activities are getting involved there, right? The legacy systems are there. So that is something you have to define your story. But yes, you need to understand, like how to play with it, right? So players are here. You can create your ecosystem, and definitely you get the right thing in place.
I think we need to move on to the next session, so I'm really sorry for that. Maybe we can discuss it out during the lunch time or maybe during the tea time and all these things. I hope.
Yeah, sorry to keep this short. We'll have to catch up. Can I now request Amit to give us the mementos to honor the speakers of this session? Yeah. So Naman, if you're on the cloud, please show up.
We'll go to the next session. Naman. Yeah.
So moving ahead to the next section now. The second session is on smart engineering using digital modeling and simulation. The industry experts, Mr. Parag Kulkarni, Mr. Vipul Kaushik, and Mr. Ravi Agarwal. A big round of applause, please. So a brief introduction about our first speaker, Mr. Parag Kulkarni. He's a senior manager, e-factory business, is responsible for digital transformation businesses at Mitsubishi Electric India. He's a Bachelor of Engineering in Instrumentation and Controls from Pune University. Later, he has pursued his post-graduation in Marketing Management from SIBM Pune. He has represented on many domestic and international platforms during his career span. Also, with his rich experience, he has demonstrated significant number of digitalization projects with Indian manufacturing industries, SMEs, and technical institutes. Our target industry segments include automotive, food and beverage, pharmaceuticals, metals, white goods, textile, etc. In this role, he is responsible for promoting e-factory solutions to Indian manufacturing industries, primarily for factory plant, digitalization, IIoT solutions with his team in India. Over to you, Mr. Parag Kulkarni, sir.
Thank you so much. I'll just test if it's working with the cloud.
I'll put on your PPT on the screen, sir. Just 1 minute.
You have the presentation, Namanji?
Yes, sir. I do have the presentation. Okay, so you can use the pointer to change the slides.
It's working. So, good afternoon. We had the first session and we had very good insightful information from all the three members who were a part of the first session. So, I would try to give you some insights about how we look at digital transformation, what are the aspects that we consider, and how we help industries achieve their digitalization goals. So, for example, there can be many stages each organization is going through. Some of them are at matured level of digitalization, some of them are beginners, some of them are just startups, or some of them are really advanced. So how we look at those levels and how we help people to take a look at what are your objectives for digitalization, from where you have started, from where you are, and how you should progress further. So I would try to cover it as early as possible so that I don't become a block between the next speakers and the lunch coming. So these are the factors that we consider when we think of any IoT or any digitalization system. So if you see on this slide, we have tried covering all the aspects that go around, and they have many aspects that we deal with. So there can be like digitalization and integration of vertical and horizontal value chains. We saw it in the movie from Mr. Chari already, okay? And he is mainly talking about the utility monitoring. However, the same can be thought about for production monitoring, traceability systems, child part versus the main component traceability. So all such systems we can think about in this first goal. The second one is like digitalization of the product and services. So if you see now many softwares or many software platforms for digitalization, they are coming like as a SaaS model, right? It's getting a popularity in our market as well. So one way is to look at it as a service. The other way to look at it as a perpetual model. So what preference our people or our customer give is for the perpetual. That's the observation we have. So people still want to go to the same mode that if I invest into a software, I should be in a position to use it for 10 years or 15 years or 20 years, rather than, paying it at batches or paying it at regular intervals. So we have to also look at what are the sentiments the buyers have, and then accordingly align ourselves. It's a very important step, and it's a learning curve for all of us, I guess. And the third, if you see, this is like digital business models and then customer access. So for example, we accumulate a lot of data. So if you assume one asset, for example, equipment as an asset, and we keep on adding the attributes to an asset. For example, a pump. So pump can be from ABB, can be from Siemens, can be from, let's say, Hindustan Motors and so on, Bharat Bijli and so on. So pump is a pump. So in a plant, we may have like HMC kind of case, we may have thousands of pumps working. And then how to create data about those 100 pumps. And then we need to define which are the 150 or which are the 50 from this 1000, which are really critical and they are working 24/7. So this kind of asset information we can build. So we have a unified way to program such assets. So we just define one asset and we copy paste them, regardless of who is the manufacturer and what are the attributes, other attributes attached to it. So it helps you to gain information about those assets over a period of time from the day you start implementing your system, your digitalization system. This is one example of customer access. Another example can be like you accumulate the data on vibration monitoring of a specific equipment, you put it on cloud, and then you have the data from this individually, all the customers, you have the data available on cloud. So you can practically look at into 100 customers of yours, how they are using this equipment and what is the critical aspect upcoming, or can we avoid any predictive failure about their equipments. So this is something which we cover from the point number 3. Moving forward, I hope it works. So I mentioned towards beginning the objective for the IoT system. or IoT system, too many times. So these are the objectives you see on the slide. So one objective can be traceability information. Today everybody is talking about EV, and the EV must maintain the data of every battery for 6 years minimum as a mandate. So to store this data for 6 years, you need a lot of, you can say IT infra, and you should have a lot of systematic approach to store this data reliably and then retrieve it reliably whenever you want. So it's not easy, okay? And you should have some provision in the system wherein you are able to do it at a go when you want information about, let's say, a battery which was produced in 2016, and you have a recall after, let's say, 22. Sorry about this. Then, of course, the other objectives being data collection and data modeling. The other one can be like plant monitoring. It's more or less similar. Then utilities we have seen from the presentation of HMC already, energy and utility. Another important aspect is like paperless office or paperless transactions. So when we see from manufacturing, as example, we did a digitalization for a chemical plant, agrochemical plant in Gujarat. So we find there are many forms they are using. One person is getting this form from production, going to quality, from quality he's going to the works head, and then they are trying to store those forms manually in a file. And nobody cares. Once the form is signed, after 1 month, nobody looks at this form. Okay? So we digitalize this workflow for them, and this goes via their ERP system directly. So this makes a lot of sense, and whenever they need any specific batch card for any specific chemical produced, they can fetch it within 5 minutes. So this is one good example as to how we should correlate our goals with the IoT system. Then moving forward, you have other facets like predictive maintenance as example. Can be one immediate objective for many companies. Then of course we should have also remote monitoring, or let's say remote access to a IoT system to control a specific area or to monitor a specific area or to see what went wrong with a specific equipment with a timestamp of all the events that have occurred on that particular equipment. This also we can solve with IoT. And of course, saving on the manpower and quality prediction. These are another goals. So how Mitsubishi looks at these goals and what Mitsubishi suggests to really make a system which is effective, or let's say it gives you the proper result for your objectives. So perhaps the approach by Mitsubishi is on your slide. So it talks about the SMKL. Okay, so the smart manufacturing Kaizen level concept. So you try to define where we are, like in terms of the levels on x-axis. You try to define whether you are on the small equipment of one of the equipment or two equipments, or you are trying to do for the entire shop floor, or you are trying to do for the entire factory, or you are trying to do for the entire value chain. Let's say 3 factories involved. So for example, in case of Mr. Chari, it was first factory in Gurgaon, the second factory in Chittor, and third factory in Bawal, I guess. Correct, Chari? Mr. Chari? Yeah, he's there? Oh, he's not around. So the 3 factories can have then access to each other's information. That's also important. So this is what we mean on the level of your target, management target. And then on the y-axis, if you see, so this talks about the functions that you want to do. So let's say collecting the information, then predictively visualizing it on the, based on the given models. Then third is like analyzing this data, which is PDCA. So you want to monitor and you want to do some control action. So PDCA, we try to apply the PDCA cycle to your manufacturing environment. And then last but not least, how can we optimize with help of AI-based tools, like for example, analytics tools. Yeah. So this is how we look at the SMKL approach. And then we try to use the necessary tools while moving ahead with the digitalization projects. So I'm trying to detail here some more, how can I say, examples. So how can you think of, let's say, facility and workers as the level 1, then entire line as the level 2, then entire plant as the level 3, and then finally the entire value chain or the supply chain. So I'll skip this because this is too detailed a topic and we will spend a lot of time, but then I will quickly give you some examples how we can look at level A, B, C and D. So here you can look at, for example, the first example is getting a data or collecting the data. So here you can use database management or FTP as a mechanism, and then we try to solve it with our existing technology. So here we use make use of both hardware collectors or hardware data concentrators or software data collectors. Both possibilities exist. The second one is like visualization, wherein you try to do data modeling based on your needs. So it can be daily, weekly, shift-wise, bi-weekly, whatever you choose. The third one is like your process image, or you try to analyze the data, what you have collected. And the fourth one is like, how can you try to improve, or how can you try to optimize using an AI technology. So this is a small way that we can look at each of the system and its requirements. I will skip some of these slides. Are you there, sir? Namanji?
Yes, sir.
Yeah. So this is another, like, we may find it going into back to the theory, but then this is also very important, like the ISA architecture, which we try to correlate with our program. So here we try to define the layers, the L1 layer, the L2 layer, the L3 layer, and sometimes you have an overlap between the L3 and L4 layers. But very important that we want to always be with our customers for all the layers, and we have a solution or we have an interface possibility at each of these. Yeah. Not to take too much time on this slide. Namanji. So this is maybe a extended view of what I explained on the SMKL. So if you see the objectives, or let's say the level of digital maturity, if you try to take a look and we try to correlate with these indicators as to what is my objective and where I want to head to. So it gives a crisp idea as to what should we be doing. Now this is our model for the digitalization. So one slide back, sir. No, ahead. Thank you so much. So if you see this slide, as mentioned by Mehta-san also towards beginning of his dialogue, this concept was launched in 2003, way back in 2003, and the Industry 4 program was launched in Germany around 2011. So if you really see, this was adopted by our parent company, Mitsubishi Electric Corporation Japan, way ahead of time. And this was implemented also in 2 factories before 2006. Okay. The green portion, if you see on this pyramid on right hand side, it represents your shop floor. Those from automotive can clearly correlate this. And you have your controllers like PLCs or the DCS or the robotic controllers or the CNC controllers sitting in this layer. The middle one, which you see in brown color, is typically your analytics layer, where you are trying to get data from the layer 0 to layer 1 or layer 0 to layer 1, and then you are trying to create data models here. And the blue layer on the topmost, if you see, this is your enterprise layer, wherein your enterprise systems are sitting, let's say for example an ERP, and then you need to create a plugin between your ERP system and your production data. So we are able to help you with one model throughout. Okay, so we are able to give you a bi-directional exchange of data, not just one direction. Okay, and this is the beauty of this program. It's very easy. It tries to give you a simplified mechanism to push your data, manufacturing data, into your let's say enterprise data. And here we are using very easy methodologies, so even lay people or somebody who doesn't know programming, let's say JavaScript programming, or anybody who is from the manufacturing environment can easily understand and configure the systems. That's the approach we take. These are the industry segments that we are present. So naturally, automotive being our strongest industry segment. But apart from that, we are also doing building automation, or let's say AHU monitoring systems for multiple companies. Food and beverage also is a very focused segment for us. Here, this slide comes from government and military. This comes from our company called Iconics, which we acquired around 2019. So this system is used for the access control at Pentagon. That's why you perhaps see a segment of that kind there. Manufacturing industries, oil and gas is also one of the focus segments. Pharmaceutical, and we also have transportation and water. So water treatment, water distribution, and water desalination. So these three aspects we are working. We have a complete division which takes care of this kind of projects across India. So on this slide, I will just try to explain you. There are three kind of partner factories, how we approach all the customers. So we do not approach the customers directly by ourselves. If we try to cater every customer by ourselves as MEI, we are not in a position to cater because the demand is too high. So we created three categories of partners. So the first category is like software partners, or we also call them as our alliance partners, and who have good experience in terms of executing digital technologies or digitalization technologies or platforms. So this is a stream that we use for such project realization. The second partner family we have is SI family. So these are typically our system houses or system integrators who know our automation products like PLCs, drives, servo, HMI, and maybe industrial PCs. And the last one is like device partners. So for example, here we try to get into partners who use our chipsets to build their products. So for example, wall banks, or for example, let's say some products like encoder products, which are using our chipsets and making our protocols available with them. So this is the way we look at it, and I'm happy that I already see three partners from our family sitting in this hall. So thank you for making it here, Mr. Mirza and Mr. Ashish, and also Anupam ji and Pradeep ji. Thank you so much for being with us. So this is the high level capability matrix. So if I see this from a manufacturing perspective, so if you can imagine, this is your shop floor from the bottom. So you have two possibilities of getting the data. One is like getting the hardware connectors or hardware plugins which are available with the PLC systems. The other way is to look at is like the software gateway, let's say OPC layer for example. And then you try to get all the functional aspects covered, including PPC for example, or quality, maintenance management or preventive maintenance, the traceability, equipment-wise data modeling, and then of course material management or warehouse management as one of the module. And also we try to get workforce performance tracking. So there's also possibility of doing this in the system, same system. Then we try to create models based on the data. We try to analyze this data under the edge analytics layer. So we have a complete program of edge devices which are useful for such activity. And then we try to send the crisp information or the quality information to a cloud with help of either OPC or MQTT kind of technology. Okay. There are some sample dashboards for you. I will not spend much time on this slide, but just to give you quick idea. So if you see there, here, we have a module called KPI works. Everybody knows KPIs. So what it means is like you have quick configuration possibilities and you can deploy the interested parameters of your choice without any programming assistance. So this is also called as self-service dashboards or intuitive dashboards. So this is a feature which we support on our visualization tool. And this is similar to your Power BI tool. So you don't have to invest again in a Power BI or Tableau or any other device or any other tool. Okay, I'll skip this. This is just a dashboard to show you, like for example, this is an example of quality management system, and then you try to give indications about the correct product being bottled or QA passed or QA failed, kind of go no go kind of indications, or you can also have a track performance. This is an example of typical maintenance management system. So some dashboards for you. This is an example of inventory management system. So you can consider all the elements of a typical warehouse management system. Skip this. Skip this. So if you see here, it's a small example, but it gives you an idea about how AI is used. For example, you have a area scan sensor, or you have a sensor on the tip of the robots, and they, whenever they sense an obstruction, they stop safely. Okay, this is one way. The second way is like if you have an area sensor around me, like P&F friends from this hall can know it better. So if I have a, let's say, 2 meter periphery around me, and I want to do a fenceless operation with this same robot for a safe purpose, I can do that using an area scan sensor. Anybody who is coming in 2 meters periphery the robot will stop. So these are some ways that we can use innovatively for the robotic applications. So this is a new product from us. This is called as the MailSoft Gemini, and this is a 3D simulator software. So you get a rich library of all the components. It's the simple drag and drop function which you can use, and it gives you immense flexibility in terms of designing any turntable, or let's say end of line packaging kind of conveyor system. It gives you all the flexibility in the world. And it can also help you to integrate third-party robots. For example, in the same system, you have, let's say, Fanuc Robo and Mitsubishi Robo. So you can adapt both the models there. So it doesn't stop you with only one make. This is the mode, or this is the approach that we take for any big project realization. So for example, we take a systematic approach as to define what is the need of or the objective setting, then detailed designing, then implementation, and the installation, testing and debugging, and last but not least training and handover. So this is an approach, comprehensive approach we take for any big size digital implementation. And we observe that there are many change requests from the customers. So as we progress and as we try to close in on a specific objective, we, by naturally it happens that we have some change requests coming in. We try to address them, and at times we have to also limit them. Okay, this is part and parcel of life. So I'm just trying to show you one example of a typical system implementation. So I mentioned that in earlier slide when I was trying to present about it. So this is an example of 3 plant locations like Hosur, Tiruvallur and one plant in Malaysia for a big automotive customer. And then we are trying to take the information from all these 3 manufacturing sites on a common platform, and then we are using also a VMs concept, okay, on the main server. One example for you. The other example I will try to show you is about again energy monitoring, and then you have 4 locations, 4 different plant locations: Pune, Bangalore, Haridwar and Nilai, which is in Malaysia. So we are trying to do an integration of more than 1,000 plus energy devices into this system as a common system, using the gateway or the edge devices as the gateways. And the third example I'm trying to show you is about pharmaceutical setup. For example, any formulation setup, wherein you get always a mix of PLCs. You don't get only one makeup PLC. You take any example of any end customer. You get Siemens, you get Mitsubishi, you get Rockwell, you get sometimes Omron. And the life there is not so easy because people think that we cannot integrate all these different makes. So we try to help them for integration of such systems. Thank you for your attention.
Thank you, sir. Thank you so much. अब क्या हुआ इसको? Okay, so can we have our next speaker on the stage, Mr. Vipul Kaushik? A brief introduction about Mr. Kaushik. Mr. Kaushik is the Assistant General Manager of Maintenance at Subros Limited, brings a wealth of experience and expertise to his role. With a Bachelor of Technology in Electrical and Electronic Engineering from CSJM University and an Executive MBA in Operations Management and Supervision from the prestigious Indian Institute of Management, Calcutta, he possesses a strong educational background. With over 22 years of professional experience in the automotive industry, Mr. Kaushik has worked in prominent companies such as TAFE, JCB and Tecume. Throughout his career, he has demonstrated proficiency and leadership in various aspects of maintenance and operations. And with his extensive experience, a strong educational foundation, and a focus on innovative solutions, Mr. Vipul Kaushik plays a pivotal role in driving Subros Limited towards achieving its objectives in the ever-evolving automotive industry. Over to you, Mr. Kaushik.
Good morning, friends. Everyone is sleeping mode. Huh? So I'm not as a speaker, but I would like to share what I have done, when I have attended some these type of presentations, and what are the questions in our mind. I am basically an electronic engineer. and having a 22 years of maintenance background. So I have started this particular journey with the Subrus. For the IoT, automation, digitalization, all these things, every one have something that we need to do these particular things implement in their plant. But what I have seen in the presentations, many questions, like just sometime before we have asked 3 to 4 questions. So I just made my presentations with these questions only. So presentations can be made any way, but as a listener or audience, what are the questions in our mind that I try to discuss in this particular form. So basically, for the digitalization journey, what prompted the decision to pursue digitalization, and what are the premier challenges or needs that you aim to address through the initiatives? Like in your organizations, you have so many targets, you have so many KPIs, but why we need digitalizations? So we will go by the slides journey. The first question comes, why we need? And if we need this particular digitalization or some IoT platform, so how we'll go across our implementation journey? What are the roadmap? So basically, to implement anything, we need some roadmap. So I will try to explain this particular thing with this presentation. If nothing is visible to you, I would like to explain each and everything with my mouth. So don't worry about this. So what are the technology partners? In initially 2020, 21, 22, I have visited many vendors like Rockwell, Mitsubishi, and different vendors. Some are the starters. So we need to understand what are our needs. So we would like to implement our needs into the actionable points. And what are the data required? Like if you are working in a production, if you are working in a medical, or if you are working in some warehouse, so what is the actual data required you? That is the key point. I would like to request, please go slide by yourself only. I will explain as per your speed. So digitalization is need of now become in every organization. Now we need to digitalize the data. We need to digitalize the, we would like to remove the paper less factory. We would like to remove their check sheets. So what are the operation efficiency improvement? Operation efficiency becomes with the operator, with the maintenance, with the quality person, with the production guy. Everyone has involved. So how we can involve on the real time? Basically, yesterday what happens, we cannot do anything. We cannot change anything what happened yesterday. So we need the data on the real-time basis. So for the real-time data, we have some machine, we have some controllers. So we need the data, we need the plant time. We need the actual product, what count have been done till now, and what is happening, how this plant data increase, that we need to work. So connectivity and communication, we are already seeing from morning, connectivity. So before implementing any project, so we need to work for the connectivity. Like some people are doing from Wi-Fi, some are doing some Ethernet network from RS-232. So we need to decide what network will be suitable for your plant. So we need to work, these are the basic backgrounds. We need to work for that. Accuracy enhancement, data information accessibility, operation data analytics. So these are the basic 6 to 7 needs which come in every organizations. So now next, we would like to explain. This is basically a simple example for operational efficiency improvement. Now my machine is running, so we would like to know the status of my machine in real-time situation. We would like to know, is there any trouble in the machine? We would like to know availability, performance, quality, what is the overall equipment efficiency of that particular equipment of that particular line. So what are the ideal loss or operation losses? We would like to see on some particular end-on. If this end-on is situated in front of
a operator or in some of line leader. So line leader should not go to a particular machine. What is happening in the machine? We should not go bother what's happening, because production pressure is everywhere. So we would like to understand how we can help to the line leader to overcome this particular pressure. So we design in the Subros this particular screen. So it is can be seen everywhere from the line. Line leader can see from their laptop, from their machine, from their office, anywhere he can see this particular screen. This is a particular end-on. Now, this is from 2023 particular screenshot, where we have some plan, where we have some actual, what is the variance. And what is, now we have worked for losses, like there are some losses less than 5 minutes, less than, more than 5 minutes. So we just analyze these things. So we just have discussed about the connectivity, how we have to be done this particular connectivity. Now we have divide particular operation, particular office, particular plant in 3 sections. Like we have divide heat exchanger division, compressor division, and the plant 3 completely. And these particular sections have been to a OT layer, and then it is local and local database IoT platform, which we have used Iconics Mitsubishi platform. For accuracy enhancement, what we have to be done, operator is working on a particular machine and he has to be enter or select some model, or he has to be enter a operator ID. Why we need this particular operator ID for accuracy enhancement? What happens in the November? We would like to be analysis today. So why this accuracy is low down in the month of November? How we will come to know? So if the data is real time available, and it will go in a database, so we can analyze. We have developed some application so that we can find out what is the OEE that particular operator or that particular model which we are running on the line. So we can analyze this particular data from this particular sheet. Now, there is a data information accessibility which I have discussed. There is a log. What is the ideal log? Ideal log means operator is on the machine. He knows the cycle time is 20 seconds, but he can produce the product on 18 seconds because we have some old machines. So in old machine cases, there are some manual operation. The operator complete his task in 70 seconds and 3 times he is ideal. So line leader cannot understand how to increase the productivity. So to increase the productivity, we have some ideal logs. So we can analyze maybe on weekly basis, maybe on monthly basis to analyze that data. Operation data analytics, like we have implemented this in particular July 2022. And what we are increasing the productivity, because I just share example of the operator inefficiency. He can do the work in 70 seconds and just doing after the shift. There are the breakdown, machine under breakdown, that's why production is less. He has so much excuse and we cannot produce, we cannot have some pressure on that particular operator. So what we can do, we have just keep an HMI, human machine interface, on that particular operator. He will able to see that, oh, this is ideal loss. Someone can ask with me. So without a pressure, we just give the awareness, that particular operator, we can increase our productivity. Like we have divided this particular manual data entry, which is by the loss entry, we have made this particular sheet. So operator himself can enter this particular data from the machine wise. Like if line is running, the operator want, I would just put a loss in that particular machine. And but if line is running condition, we have take the running input, that particular PLC, that particular controller, so operator cannot feed wrong data. Yes. This particular line diagram, which we can have the line status, like it is running in green, yellow is ideal, red is under breakdown. We can see that this particular thing from the line diagram. If we are just standing in our plant on a particular line, we can see these particular dashboards. This we have done with the FANUC integration with the Mitsubishi Iconics SCADA integration. Like we have availability, OE efficiency, some OE parameters, spindle speed, feed rate. We can monitor and we can analyze what happened in the past. So like I just started with the time bound. Like, do we need a time bound? Because in any organization, KPI are given in the month of the March or April, are decided for any employee. So anything should be time bound and should be there a roadmap. What are the major steps you require to develop these steps? Like what I have done to access current state. What are the defined goals? Identify key technologies, prioritize initiatives, develop a roadmap, engage stakeholders. Engage stakeholders is a key thing in this particular journey, because if I am from maintenance or I am from a digitalization expert, but what is about the production people? He don't want to use what you have developed. If he doesn't use what you have developed, it is useless. So we need to engage stakeholders from quality point of view. Like some people have asked some question, what is about quality labs? So we need to initiate, before implement any project, we need to be engage all the stakeholders from the top management also. Because if there is no interest of the top management in these particular things, so there will be a lack of budget and all other constraints. So we need to make some CFT and discussions based on the CFT. Now, seventh point is the pilot project. As I already shown you some line diagram. So before starting our this journey, we have implement on the seven number machines, where 4 machines are the upgraded version of PLCs and 3 are the old version. Because Subra is a 28 years old plant, we have old machines, new machines, variety of controllers, die casting plant, compression plant, heat exchanger division, molding machines. So we just implement a pilot project and we try to understand what are the issues, like network connectivity issue, what will happen if these issues happen. So all these things we have done. So for steps for developing digital transformation roadmap, I have done the data collection first, data visualization, data processing, and now we are working for the enterprise connectivity. What we have done in the last 2 to 3 years, we are trying to connect all these data to the SAP. I would like to explain the roadmap. Like in this roadmap, we have decided the themes, like for visualization, digitalization, and for the utility equipment, as I think Hero MotoCorp, my friend has already explained, he has done a fantastic job for the utility. For the bin data logging, for the stored management, for the smart machines, we have started to put the smart sensors on the machines to have the data for their vibration, for their temperature, humidity, all this data, and we can analyze these particular data after a time. And the control processing, we have started the traceability, as this is the now requirement for any OEM for the traceability, product traceability. If we are supplying 80 to 84% these particular HVACs to the Maruti. In the India, we are supplying 82%. So what Maruti is requiring, if my car, for Maruti car is failed after 4 years, that particular HVAC product, so he wants to track all the details of this particular product after 4 years, because it may be in warranty. So we would like to be traced back. So to make a happy customer, we would like to be do some work for the traceability. What question may be next? What kind of data we would like to be under digitalization, or what may be the benefits of this particular data? We would have some process parameter data, production data, energy data, maintenance data, attendance data. So process parameter data will help us to improve the process accuracy, process product quality. Like in production data, we have already seen how to increase the productivity. Energy data, we have already studied many times. We have many questions for the utility, that like we have some machine for particular operation, and we have put some energy meter on this particular machine. So what happens? We know what is the consumption, but we never know how to improve, how to reduce this particular consumption of that particular machine. So we have started work out for energy hungry machines. we have the production data, we have plan and actual. Now we have put energy meter and we have clubbed all this particular data to know energy hungry machines. Which machines, because the target was the 400 part yesterday, but we produced 390 parts. So these particular 10 parts which give some information, some analysis, why this machine has power consumption has been increased. So we can analyze this particular data from the energy EMS system. Now, what may be the benefits? I have already explained: enhanced efficiency, predictive maintenance. Predictive maintenance can be done by the smart sensors, quality improvement, and the cost reduction. Yes, cost reduction is the major part of any organization. Why we would like to implement this particular system? So this particular system has to minimize, if we increase the productivity of 1% in a particular plant, this 1% productivity give our the cost reduction in many factors, like for manpower reduction, for machine capability. All these things give the cost reduction automatically. We don't need to bother. This data will give some cost reduction or not. Yes, next please. I have already shown online monitoring of process parameter through digitalization. Yeah, this is process parameter of some machine. This machine, this is helium leak test machine, and this helium leak test machines give part OK or NG. If we are checking 1,000 part yesterday, it gives 80 to 85% NG parts. So what we can do? We have the operator just write down. But if we have the information of that particular leak rate or NG data, then we can improve. Otherwise, we cannot improve this particular thing. So we can do this in these things. OE analysis sheet. Now, what we have done, like we have total 16 losses all over the world, and we have captured 12 losses. We have studied these 12 losses can help us to analyze what happens yesterday in the particular production system. On the basis of this particular system, we have the shift-wise, day-wise, month-wise report. These reports can be generated and can be shared with the production head, maintenance head, as well as the line leader. Even we can share these reports to the plant head. Plant head come to know what happens yesterday or what is the cumulative data, what is happening in the plant without just giving some information by the Excel sheet. Because the Excel sheet can be manipulated, but this particular data cannot be manipulated. This data is coming automatically from the machine and can be seen throughout the day. This is some data which I would like to share you. Energy consumption. Don't want to go in the details this particular sheet, but we have done some water management system. We have provided online groundwater, STP, ETP, water consumption meters, and we understand that how much water is just wasted because we just putting these data in the logbook something. Then if these data goes to the escalated to the plant head, production head, maintenance head, then we will come to know how much water we are wasting. This particular data, we are just benefit. You have seen what are the discharge we have made in 2022-23 reduction and 2023-24, what is our target. Next slide is what is the benefit for the customer. Like we are some vendor for some company, maybe tier 1, tier 2. So what is the benefit to the customer? We would like to understand, because this is like quality, customer is our pride. So we would like to understand customer requirement, customer benefit. So product traceability, I have already explained. Vision system, like we have some machine, we have provided some vision system. So there, this POCA-IOK will not lead to any defect to go with our customer. So this particular real-time feedback, what is yesterday feedback, what we have made, what are the OK products, whatever the NG product, what are the traceability, these can be gone to our customer by developing some software. He can understand what is happening in our tier 1 or tier 2 company, like customer relationship management system. Traceability, I have already explained. Vision system, I have already explained. Thank you. Thank you. Thank you.
Thank you, Anupji. Very good noon to all of you. Wonderful set of presentations since the morning. Quite insightful, I must say. Sitting under the aegis of Foundation for Smart Manufacturing, 7-8 years ago, when DHI gave us this mandate of how can we proliferate smart manufacturing in India through sensitization, hand-holding, training, it was a big question that all these concepts, how do we really communicate and germinate within our manufacturing ecosystem? Yet, the presentation since morning and many as have happened in the past have been a big sigh of relief that within our Indian manufacturing landscape, the absorption, assimilation, and coming to a shoulder level of what's happening elsewhere in the world, vis-a-vis IIoT, Industry 4.0, or e-manufacturing, I guess seeing the international landscape, Indian manufacturing industry has accelerated its learning and more so the implementation of these concepts. So in a way, it's in step with the rest of the world. Why I say what I say? Is Industry 4 or smart manufacturing question of automation? What kind of automation equipment do we use? Is it the question of connectivity of machine data, manufacturing data, production data, parameterization, etc., to the relevant layer? Or Industry 4 or smart manufacturing is really making a sense of this data? See, information is the key. If you can digitize your information and communicate it, the real Industry 4 is actually making a sense of it and deploying it for the benefit of the manufacturing, thereby making it competitive. That's one perspective I would like to lay before you. Because here, Industry 4 is not only about different layers of automation or data communication, but it's about making more sense of it. And when I see the presentations as have happened today, it's a big sign of gratification that our manufacturing companies, be it vendors who are doing the stuff or the end users, are bringing it to that edge where now there's a lot of data, there is canisterization, there's segmentation, there's a little bit of IT and OT interface, you can say. There is a lot of OT data, I would say, available now for the analysis. And that, ladies and gentlemen, is no small a feat. While I congratulate everybody in this room and elsewhere in the industry landscape, prompts me one question to the dignitaries on the dais, starting with you, Parag ji, one question. as you were presenting this fantastic concepts of e-manufacturing and e-factory. Within your experience in our local landscape, what are the generic pitfalls in last few years you have actually witnessed or gone through that you would like to share with the audience so that this sensitization and learning from your own experience, we can be a little bit smart step ahead, I would say. Over to you.
Yeah, thank you so much for insightful question itself. So I will say objectives. I mentioned and I deliberated on my presentation about objectives. So if you have written down objectives before you start from anywhere, any level of maturity, then the pitfalls will be definitely in control or within control. However, if you start in a haphazardous manner and without taking a real, how can I say, sum of where you are starting from, then naturally you will have to pay some cost. You will have to pay the cost in two ways. You will have delayed projects. It's not like you did not reach where you want to. You reached, okay, eventually, but you reached maybe 3 months later or 6 months later or 9 months later or 12 months later. And then this extra months is cost. It's cost in terms of human effort. It's cost in terms of, the, how can I say, the headaches you have because then you are not on track. And finally, it's like also resource pooling within the organization where you are trying to do this. So you're trying to pull more resources or you're trying to get extra burden on yourself or you have sleepless nights. Yeah, all this is real. This is not like imaginatory or this is not imagination. This is real. So these are the pitfalls. So and just to sum up, it will be like easy that we should know at each point of time what we are trying to do. What is my goal for short term? What is my goal for mid term? And what is my goal for long term? Like Chariji I am missing him on the dais here, but then he has really helped us to see how we want to grow. Or for example, Kaushik ji also is our customer, happily sitting next to us. So they have really helped us to identify where we want to start from, where we would like to mature to, and with which plant we would like to start first, which plant as next, which plant as third. So we went always with our strengths, like Gurgaon being closer to our office. We started with Gurgaon location first for HMC, later on for Bawal, and later on for the plant in South. So it also takes a good, how can I say, thinking as to where is your strong point is. What are your strong bases? Where are your resources concentrated? Where you have skilled manpower? Where you do not have skilled manpower? All those metrics you will have to put together. I believe I could respond to you properly.
Thanks. In fact, that's also insightful. I guess you are pointing towards a clear problem statement or a problem definition and also a precluded roadmap as to what would be the journey to the destination. And I saw from your presentation, Vipulji, that the roadmap to digitization and yourself being so much experienced in O&M and coming from a very good brand, having the wherewithal to put a digitization layer onto your factory. Now, myself and Paragji represent the vendors for the hardware and the softwares for automation and digitization. So as an experienced end user having gone through this journey, what would you red flag in terms of the expectations or the gaps you experienced from the suppliers and the contractors in your journey of digitization?
Thank you, sir. Thank you. Basically, when we started this particular journey, we doesn't want do some digitalization, some IoT. Management doesn't want some digitalization. Management want productivity increase. Management want utility cost increase by using cost-effective solutions. So we have visited Rockwell, Mitsubishi, and many more startups. I should say more than 60 startups we have visited, their applications we have seen. So what are the issues in there? Because in Mitsubishi in startup, I would say the name in Mitsubishi, Nikhil. He helped me like this. आज तो अच्छा है 7 मशीन का कर लो, कल को क्या होगा जब ये 70 मशीन हो जाएंगे? 7 मशीन में तो नेटवर्क पे जो डेटा चल रहा है ना वो थोड़ा सा है. जब 70 machines पे data will travel and it will go to the server, what will happen then? When data will go with the speed of per second, or in a second, huge data is go. What you will do? So initially, I was in trouble that no rework, like say no time will increase because I have done something. I have developed some network, and after some time, maybe 6 months or after 1 year, I will redefine my network. So we should work as per our requirement, network development. Then choose a solution. Maybe any solution will work for you, but as per your requirement, network and this particular solution. Like someone has asked for the molding machine. We have molding machines, and this particular molding machine OEM doesn't allow to touch their particular control system. We have molding machines of different vendors. So what we have done, as I think sir has told me, we just provide a single PLC, because any input, any machine, any controller have inputs and outputs. We just use them. Take all the inputs to a particular controller and give these particular by the Ethernet network to the SCADA system. And we develop what is our requirement. The same screen, same dashboard, and same records analysis will be available for us, even for the parameter also. So we just need to understand first our requirement. Then we should develop our roadmap. Thank you.
Well said. Repeating or coming back to you, with your experience of whatever digitization you have done, just a quick one, would you expand it to your entire plant as a success story further?
Basically, this is not a question ki I would like, or our management particular plant head would like to expand it. Now, by the benefits, the management has, the top management CEO, Mr. Amit Parashar of the Subros, has started to implement these things across all 8 plants of the Subros. And they have just standardized. What we have done in Noida, just share to the other plant. What we have done in the Manesar, please share to the other plant. And I would say these particular things which we have last year, this presentation of the last year, maybe in the last 7 to 8 months, we have done drastical improvement, and the drastical speed, we have catch up the speed. Like we have done something in our Noida plant in 6 months, but in the Manesar we have done in 1.5 months. By using our experiences. So we are doing in all our plant. Even one question was there that we should go to the tier 3 from the Maruti. Yes. So we are working with our SCM team to implement this system, and even we are helping them to how we just sharing what we have done and how we have done in minimum cost. Just we are doing these things.
So the experiment now has become a necessity.
Yes.
Wonderful. So gratifying to hear. With the permission of the program director, maybe we take a couple of questions from the audience. If anybody has a question, please. Yes, please. Maybe the mic can be handed over. Can you please raise your hand again so that the mic can be handed over to you?
Good afternoon, all of you. Sir, I am PhD scholar at IIT Delhi. I work in vibration analysis of machine. So I have, both of you have presented in digital tune and machine learning. So I just want to elaborate, I just want to know more about the digital tune, because if you are handling a machine where there are motors, are there bearings, gear and different parts and different defect like earlier told, and you have implemented sensors and you are using machine learning algorithm to predict it and to tell in advance that when it is going to fail, that is remaining useful life of the machine, but that is like sensor based. That is not a digital tune of the whole machine, because for that we have to put several sensors to a machine. So the same question that is raised by you, that today there are 7 machines, but what if there will be 17? So how you take the digital tune into account? And what does the industry understand from the digital tune point?
Okay, that's a deep-rooted question related to smart engineering and modeling per se. And I heard the word vibration monitoring. So I would separate these two parts as you would also like us to do. Digital twin is now a precursor to intensive digitization. When we started our journey in FSM, the lines which we have built, you would be having an opportunity to have a look at them subsequently. The whole idea was right from the scratch, when you start putting a CAD CAM together and visualizing a machine, the benefits of the digital twin get realized when the machine actually starts functioning. And when you have to disseminate it to different vendors, give them the right instructions, to the system integrator, putting the mechanical assembly together, putting the digitized controls, sensors, inspection systems together, the digital twin becomes the language of communication for machine inception, realization, and commissioning. And talking about vibration, I guess we have the stalwart from the O&M on vibration and vibration as related to digital twin. Maybe you can throw some light on that.
For the vibration, just you have asked that we can put some sensors over a single machine. But now, these particular things can be developed by a portable condition monitoring based system. We can define some control system, some algorithm, some sensors connected with some connectors. And these portable things can be moved to one machine to another machine. The same thing we have done in our plant. We have put a portable things. This control panel have this PLC, like Sir has already shared, that PLC also having some memory, like in mobiles, having the extended memories, and can be connected by the Wi-Fi or the Ethernet network. So we can define by portable things. Like we, other than the condition, like vibration, we maybe have temperature, we maybe have some humidity. Maybe we need to know the temperature of maybe 12 zones. So it can be increased in a modular PLC and can be portable to one machine to another machine depending upon the requirement. Like if one machine have some 4 inputs, we can connect this to the 4 machines, 16 inputs at a time, and having the data of the 24 hours maybe for 1 week, and we can then move this particular portable condition based monitoring equipment to other plant or other equipments. Thank you.
Thanks, sir.
I would just like to add one more line. So we have a product, directly usable product for vibration monitoring. So it uses FFT, as most of the equipment manufacturers use FFT for the analysis. The beauty here is you have a ready-made program given to you on the HMI, and it takes 2 or 3 days to commission it. So what it means is you have a pre-tailored GUI made available by Mitsubishi, tested by Mitsubishi, and you can connect sensors like IFM sensor or any other standard method sensor. The only constraint here is you should use a type acceleration type sensors, not the velocity type. Okay. That's all. The make is like not very important.
So, sir, what I understand that you are saying that you have a physical model, physics-based model, and through some of the sensor of acceleration base, you can monitor it continuously, and you can tell that when it is going to have defect.
Yeah. And you can have multiple sensors. For example, we don't restrict you any number of sensors. You can choose freely
of acceleration
2
type.
or 4, yes. So you can use either a triaxial sensor or you can use a single axis sensor. Both is possible.
But sir, many times these acceleration sensors are not enough. Like we see that in where they have heavy machineries, their gears are there. It normally breaks, like turbo machineries and all normally break because of torsional vibration.
So it comes by like experience, as you rightly said. So with a big motor, let's say a huge induction motor, maybe one axis is not enough. Yeah. So you have to use multiple sensors at 2 or 3 different locations. That's the way to do it. Okay.
Thank you. Thank you very much, sir.
I guess one part of your initial question was that through vibration sensing and analysis and a digital twin, how can you replicate it multifold for preventive analysis? That's how I understood it. Now, vibration is a very, very, very typical creature, I must say, because vibration of a machine is very, very personalized affair of that particular machine. Machine of the same yawner lying at a different place will give you different characteristics of vibrations. So the whole idea remains that in experiential learning, once you have a realized actual twin of your digitization and you have experimented with the pilot, what are the minima maxima parameters of vibration you would like to analyze or capture so that you can incorporate in the design when you are going to replicate the digital twin for your mass production of a machine. Because down the line, I believe that vibration criteria for a particular machine will also get typified so that the monitoring of it and preventive maintenance parameters can also be actualized in a smart machine. But it remains a highly personalized affair for a particular machine, because how a machine will actually behave depending on the drive, the bearing life, the lubrications and so on and so forth starts to differ.
Sir, that's what the question was like. If we can replicate the whole part digitally, then I guess rather than keeping multi-sensors, if we take 1 or 2 sensors at critical location, because we have a digital replica of the whole machine. Let's say for a motor, we have a digital replica. So if we take a output from one sensor also, that should be responded and that should be visible in our digital replica. So through that, I guess our usage of the sensors also may decrease a little. And we can implement at each location for each machine separately.
By experience, I can tell you one sensor wouldn't suffice, because minimum 2 dimensions with defined amplitude are very necessary for any kind of preventive maintenance vis-a-vis vibration.
Thank you, sir. Thank you very much, sir.
Any other question, please? If not, then I once again thank. Yes, please.
Sensors. Those have been explored maybe globally, but in the mediocre companies, in the companies where we are talking about tier 1 and tier 2, those type of sensors are not been into practice. Maybe especially the pinch sensor, finger pinch sensors and all this kind of thing. A lot of accidents happen. How the sensor manufacturing companies are exploring and advancing in that direction? That is also very important as far as digitization is concerned, and how we're going to make the things more reliable for and people more secure in the work field.
Okay, that's a question that has 2-3 dimensions. Permit me to explain each of them separately. Vis-a-vis the automation equipment for safety, most of the automation equipment, we like it or not, have been developed in the West. So whether you talk about the Japanese, European or American manufacturing space, safety of human personnel has been a prime concern, because of the unions, because of actually sensitization towards human safety, and there are laws and there are standards. And when I say that the equipment has been manufactured or developed in the West, and there's a continuous improvement into that. So today, talk of finger protection, height-based protection, mutation, 300 mm, 25 mm, 14 mm, 18 mm, or accuracies and perimeter fencing, such equipment are already available. Talking about the digitization of them, I would say as one of the suppliers, it goes together. Last 10 years have seen huge effort in digitization and communication of safety parameters and safety space capturing. The last but not the least, the dimension of adoption in small and medium enterprises or tier 2 and tier 3. To me, it is not a paucity of equipment. It is first the willpower, second is the enactment of laws. Donkey years ago in Pepperell Fuchs, I used to wonder whether the safety products will at all sell in India or not. But permit me, 40% of automation equipment in the sensors field today is being adopted in the whole landscape, manufacturing landscape, notwithstanding the fact that small and medium enterprises are also open towards it because the cost of accident vis-a-vis the labor laws in India, and by the way, the law is already there, is becoming unaffordable. And then many of you are from big assembly plants. In your safety audits, how you qualify your suppliers also demands that what are the personal level safety features in your machines, what kind of fail-safe features are actually endowed in your plants. So I guess it's from an adoption point of view, it's a more question of mindset and affordability rather than availability of equipment, if I've been able to answer your query.
Maybe more or less some of the queries are answered. It is, you are right in that perspective, but I want to say how to make the things affordable as well, because these are very, very imperative things for today. And it is a mindset that things are, when we are going for safety, that means we cannot afford them. I could have seen some of the companies because people are not coming up front, maybe especially the technocrats and the people who are manufacturing the sensors. Today also I met some people. So there is a competition in the sensor market also. Some people are very, very affordable, but they are not, coming up front and discussing with manufacturing, users. And then people should first of all get acquainted, and they should be, they should have the know-how, how to use them, why it is necessary. Maybe as a forum also, people like Mitsubishi and all the big elite companies, they should come, and this kind of legislative things and this kind of, statutory things, those has to be brought into the practice, and people have to be more aware on this kind of situation. So it is the responsibility of everyone, not only the user. People do not use the things because they don't know. Most of the places. First of all, let them be aware about what is actually available in the market, what we can able to afford, how good companies are doing it, and how it can be affordably managed. This is the area where I think we should come up front, and we can do.
I think your point is well taken. Remains a question of how good information dispensation or education goes along with. I would again take the feather of Foundation for Smart Manufacturing, where automation safety or safety in robotics, etc., or the equipment, and also we are talking about personal safety, but security and safety of data along with smart manufacturing also is a key aspect. So I guess it's also a question of how the germination or pollination of this information happens across the landscape. And I'm pretty sure that most of the vendors who are selling such equipment are conducting a lot of education and sensitization onto that. And if not, maybe I can also on a personal level share with you some of the activities that happen on digital platforms regarding this.
Thank you. Thanks.
Over to you, Anoopji.